Okay, I'm going to go through some of the review problems and just explain them a little bit more. So whenever you have a rational exponent, so this is a rational number and the exponent because you can write it as a fraction. If I have a decimal, I always want to write it as a fraction first. So I'm going to write this as 25 to the, okay, so you got negative 1.5 is negative 1 and 5/10, which is negative 1.5, which you can write that as negative 3/2. So this is 25 to the negative 3/2. If you have a negative exponent, what you do if this whatever has a negative exponent is in the numerator, you're going to put it in the denominator and make the exponent positive. So I have to put a 1 to hold it up there. So now I can go back and I'm going to write this with a radical. So this is the same thing as 1 over the square root, because this is my denominator, of 25 and then cubed. So I always do the root first and then cube it because I think it would be more difficult to do 25 cubed and take the square root of that. So the square root of 25 is 5. 5 cubed is 125. So the answer is 125. Another problem is 4 to the 1/2 times 20 to the 1/2. So these, I can write them as a radical. So this is going to be radical 4 or root 4 times root 20. And that's more recognizable to simplify. So root 4 is 2. And then root 20 is 2 root 5. So you can write these together as 4 root 5. And then another problem, we'll do negative 27 to the negative 2/3. So again, you have this negative exponent right here. So if you have a negative exponent, write 1 over negative 27 to the positive 2/3. And then I'm going to write this as a radical. So it's negative 27, the cube root of that, and then all of that squared. So the cube root of negative 27 is negative 3. Keep it in parentheses though, and negative 3 squared is 1/9. So the answer is 1/9. What about 5 to the 1/3 times 25 to the 1/2? Oop, 1/3. So to make it more recognizable, I'm going to write it as a cube root of 5 times the cube root of 25. Since these both have the same indexes, I can multiply what's underneath and write the cube root of 125. So now I can just evaluate the cube root of 125 is 5. Also be comfortable with writing expressions in radical form. So the difference between 4x to the 2/3 and 4x to the 2/3 is that this whole thing is taken to the third root second power, but this part's only taken to the third root second power. So I'm going to write this as the cube root of 4x all squared, whereas this is 4x squared cube root. See, this one, the 4 stands outside. This one, the 4 is underneath because the 4 is within the parentheses. And I'm also going to do, if I can find room right here, if you have to write 1 over the 6th root of y, and write it with a rational exponent. So a rational exponent is an exponent that's a fraction or a decimal, or it can be written as a fraction, to put it simply. So this y is in the denominator, so this tells me it's going to be a negative exponent. So this is y over 1, y to the 1/6 power, but this is the 1/6 power on the bottom, so it's actually y to the negative 1/6 is the answer. Also, be comfortable solving square root equations, cubic root equations. So this one is 5x equals the square root of 5x plus 2. So you're going to square both sides. So be careful, and this is 25x squared equals 5x plus 2. So it's a quadratic, so I'm going to get one side equal to 0. Then I'm going to find, I have to factor this trinomial, so I'm going to find factors of 25 and negative 2. This is actually negative 2. So factors of negative 50 that add up to negative 5. So that's going to be negative 10x plus 5x minus 2 equals 0. I do that in order to factor by grouping. So I'm going to pull out a 5x of these first two terms. And then I'm going to do 5x plus 1, 5x minus 2 equals 0. So x is negative 1/5 and x is 2/5. So now what I'm going to do is I need to always check to see if these work. So make sure that you're plugging in x in the left-hand side and seeing if it's equaling the right-hand side when you plug in x. So I know already that this one won't work because this left-hand side will be a negative number, and there's no way that you can take the square root of something and get a negative number. So this is called extraneous, because when I was doing my math, that's what I got, but it's not the right answer. And then x equals 2/5. 2/5 of 5 is 2, so sides 2. 2/5 of 5 is 2 plus 2, square root of 2 plus 2 is 4, square root of 4 is 2. This works. So this one works. So I'll do another one here. If you have x plus 9 to the 2/3 equals 3. Okay, so what I would do for problems like this first, I would get rid of the cube root. So get rid of the 3 first in the denominator. So now you're going to have x plus 9 squared equals 9. Then you take the square root. You could also FOIL this too if you want, and then get one side equal to 0 and use the quadratic formula. But if you take the square root, you're going to get x plus 9 equals positive, this is 27. Positive 20 square root 27. And then x plus 9 equals negative root 27. So root 27 breaks down to 3 root 3. So you'll have x equals negative 9 plus or minus 3 root 3 as your answer. Also, be comfortable with finding if you have f of x and g of x. So f of x equals x squared plus 2 and g of x equals negative 3x. Make sure that you can add, subtract, multiply, and divide these and write their domains. So I'm going to divide these. So I'm going to do, even though you didn't have this one on your test, I'm going to do g of x divided by f of x, which could also be written as g over f. So g over f is negative 3x over x squared plus 2. And then I'm going to find the domain. So I can't simplify this any further. There's nothing I can factor on the top. There's nothing I can factor on the bottom. So to find the domain, what you do is you set the denominator equal to 0 because you don't want to divide by 0. So the domain is the denominator cannot be 0. So I'm going to write x squared plus 2 cannot be 0. So x squared equals negative 2 cannot be 0. So you're not going to hit all real numbers are going to work for this. You can plug in anything for x and it's going to work. So domain is all real numbers. So an example where it wouldn't work is I'll do this one. Let's pretend that f of x equals 2x plus 4 and g of x equals x plus 2. So to find f over g, you could do 2x plus 4 over x plus 2. So then what you want to do is you want to factor the top. So the top is going to be 2 times x plus 2, and the bottom is going to be x plus 2. So these cancel out, so this is just going to be 2. The answer is 2. So now when you do the domain, look at your denominator. You write the denominator can't be equal to 0. So therefore the domain is all real numbers except x can't be negative 2. Also make sure that you know how to do compositions. So compositions can look like this, or they can look like this. So that these two are the same notation. So if you have that f of x is equal to 3x plus 2 and g of x is equal to x minus 1. So what you would do is if you had to find f of g of x, you're going to take your g of x and plug it in for x in your f of x function. You always do the inside part first. So it's going to be 3, but now instead of writing x, I'm going to write x minus 1. So it's kind of like substituting, and then plus 2. So it's going to be 3x minus 3 plus 2. So this is equal to 3x minus 1. Now I'm going to contrast that and do that with g of f of x. So I'm going to take my f of x, plug it in for x right here. So that's going to be 3x plus 2, because that's x, and then minus 1. So this is going to be 3x plus 1. So they're not the same. So be able to do compositions with numbers too. So if you have to do f of g of 6, and g of x is equal to x squared, and f of x is equal to negative x plus 1. So what you're going to do is you're going to take 6, g of 6, and plug it in right here. So g of 6 equals 36, because that's x squared. So then you take your 36 and you plug it in for x in your f function. So f of 36 is equal to negative 36 plus 1 is equal to negative 35.